Hello my dear students, I welcome you all for SVK tutorials. In this session, I am considering the fourth semester subject called Complex Analysis, Probability and Statistical Methods. So in this subject, I am considering Module 5. In that Module 5, I am considering sampling theory. So I am going to discuss the brief problems on sampling theory and definitions of sampling theory, which comes to the examination, final examination. So I'm going to give a single examples. I'm going to solve a single problems in each topic of sampling theory. So which is very much important for your exam. So if I come with definitions under sampling theory, basic definitions. First of all, you should know what is population. A large mass of individuals. A large mass of individuals is called population. So next, after knowing population, you should know the definition of sample. A sample is nothing but part of the population. Part of the population is called sample. In sample, we have two types. That is, if the sample size is n is less than 30, if n is less than 30, then such samples are called small samples. Then such samples are called small samples. What is small samples? And sample size containing less than value 30, such samples are called as small samples. In case if the sample size is greater than 30, then such samples are called large samples. Large samples. So this is the definition of sample and population. Next, moving on to hypothesis. We should know the definition of hypothesis. Hypothesis is an assumption which may be true or false. The hypothesis is an assumption which may be true or false. Whatever the assumption we are going to consider that may be true or false, such assumptions are called as hypothesis. So there are two types of hypothesis. One is null hypothesis and second one is alternative hypothesis. The definition of null hypothesis is as follows. The rejection of hypothesis. The rejection of hypothesis when it is true is called null hypothesis, and it is denoted by H naught, The rejection of hypothesis when it is true is called null hypothesis, and it is denoted by H naught. So in case of alternative hypothesis, converse of null hypothesis is called alternative hypothesis, and it is denoted by H1. So next the definition, we will go for next definition, errors. While taking the decision, sometimes the decision may be correct or wrong. The decision may be, whatever the decision we are going to consider, that may be correct or wrong. If it is wrong, then we call it as error. If it is wrong, then we call it as error. We have two types of errors, type 1 error and type 2 error. You should know the definition of type 1 error and type 2 error, as all the definitions are important. There is a chances, nothing like chances. Definitely there will be a questions on definitions of these under sampling theory. So when the hypothesis is true, if we reject the hypothesis, when the hypothesis is true, if we reject the hypothesis, then the decision is wrong, then the error occurred is called type 1 error. What is type 1 error? When the hypothesis is true, it should be a true hypothesis, should be true. If we reject such hypothesis, then the decision is wrong, the error occurred is called type 1 error. Type 2 error, when the hypothesis is false, if we accept the hypothesis, then the decision is wrong. The error occurred is called type 2 error. The error occur is called type 2 error. Moving on to next definition, significance level. This is very important. The probability level in which the rejection of hypothesis is called the level of significance. What is significance level or level of significance? The probability level, there will be a level for the probability level in which the rejection of hypothesis is called level of significance. There are two standard levels of significance. One is 5% level of significance and 1% level of significance. So for 5% level of significance, if mod z is less than 1.96, then the hypothesis is accepted. In case of mod z is greater than 1.96, then the hypothesis is rejected. Whatever the value, if you get z value as less than 1.96, then such hypothesis will be accepted. If it is greater than 1.96, such hypothesis will be rejected. So, in case of 1% level of significance, if mod z is less than 2.58, then the hypothesis is accepted. If mod z is greater than 2.58, then the hypothesis is rejected. So, in case of 1% level of significance, if mod z is less than 2.58, then the hypothesis will be accepted. In case of mod z greater than 2.58, we will reject that hypothesis. Then moving on to important definition called confidence intervals. If we represent the mu value, the value or the area between the mean of area between x bar minus 1.96 sigma by root n and x bar plus 1.96 sigma by root n is the 95% confidence interval. In case of 99% confidence interval, the mu lies between x bar minus 2.58 times of sigma by root n and x bar plus 2.58 sigma by root n. So, this is the 6 definitions we have under sampling theory, which is very important for your examination. There will be a one question compulsory in your examination regarding the definitions of sampling theory. So now moving on to the main concepts of sampling theory, I am going to discuss only 3 topic, that is test for significance for large sample in given is given by the formula. Then I am going to discuss student t distribution and chi-square distribution. So in this session I am going to discuss only 2 concepts, that is test for significance for large sample and student t distribution. So test for significance for large sample is given by the formula z equal to x minus np divided by square root of npq, or it can also be defined in another way. If mean directly mu and standard deviation is given, we can make use of this formula for large sample. You should know that when we should apply this formula only for large sample. So x minus mu by sigma times of sigma by root n. So in case of small samples, there is an student t distribution called t equal to root n times of x bar minus mu by sigma, where x bar is nothing but summation x by n, sigma square is given by 1 over n minus 1 times of summation I xi minus x bar the whole square. Here there will be some doubts when we should apply these 2 formulas. I have mentioned here This formula is for large sample and this formula is for small samples. So though you are not understood what is large sample, small sample, when you should apply student t distribution, I can tell you that if the given samples of the type x1, x2, x3, so on up to xn, then you can go with small samples of called t distribution, student t distribution. So finally, you can have one more definition called chi-square definition. It is called as chi-square definition. Chi-square definition. Chi-square is given by summation of I equal to 1 to n observed value, the difference of observed value. OI is nothing but observed value minus expected value, the whole square divided by expected value. So here I have given the note. Though I am not going in depth of explaining the concepts of sampling theory, so I am giving whatever the things are important for your final examination. So if there are n observations, degree of freedom called df, or it is also denoted by nu, symbol called nu. This is the symbol called nu. So they can give in terms of nu symbol. So if the degree, if the given value is n, if the observation values are n, then the degree of freedom is given by n minus 1 values. N minus 1 values. Now moving on to the problems. A coin is tossed 1000 times. So this is the large samples. So you should go with the first formula called z equal to x minus square np divided by square root of npq. And head turns up 540 times and head turns up 540 times. Decide on the hypothesis. You should decide that the hypothesis whether will reject it or accept it, that the coin is unbiased. You should consider the coin is unbiased. Now let us consider the coin is unbiased here. Let us suppose that the coin is unbiased. Then as you know that while tossing a coin, the probability of success is 1 by 2. P equal to 1 by 2 I will consider. When I come to know what is P, we can find out Q automatically by using the formula 1 plus P plus Q equal to 1. Therefore, Q equal to 1 minus P, which is given by 1 by 2. And also they have given the large sample value 1000 here. So, and the expected number of heads in 1000 tosses is given by mu called NP. N value is 1000, P value is 1 by 2. So 1000 by 1 by 2 gives 500. Next, given head turns up 540 times, that is the value of x. Now considering the difference of those two, x minus np is given by 40. Now consider the general formula z equal to x minus np divided by square root of npq. So substituting all the values, you know all the values. This is n value 1000, p value is 1 by 2 and q value is 1 by 2. P value and q value. So substituting all these values, you are going to get the value as 2.53, which is less than 2.58. So you should know the level of significance. 2.58 is given for 1% level. Thus we can conclude that the coin is, as we are considered, the coin is unbiased. Therefore, the coin is unbiased and the hypothesis is accepted at 1% level of significance. As this problem carries 7 marks, so they will give the weightage for conclusion. So don't forget to give the conclusions here. Okay, this is one problem and one example of solving first type, that is called for large sample. I am going to discuss another 3 types of large samples. Next, considering a die problem, a die was thrown 9000 times. So it is again a large sample, 9000 times, and a throw of 5 or 6 was obtained 3240 times. on the assumption of random throwing, on the assumption of you are going to throw in randomly, do due to data indicate an unbiased die. Now let us consider an unbiased die here. I am considering unbiased die. Suppose the die is unbiased. What is the probability of throwing? While throwing randomly, you are getting a chance factor called 5 and 6, 5 or 6. So two things, your probability of getting 2 there. So therefore, probability of out of 6, your chance factor is two varieties called 5 and 6 faces. So therefore, probability of throwing the die, you are going to get 2 by 6, which is nothing but 1 by 3, which is given by P, which is defined as P. That is what I have defined. Once you came to know P, we can find out Q. So N is given, that is 9000. Then we can find out the expected number of success is NP is given by 9000 into 1 by 3, that gives 3000. This is expected number of value. Now observed value, which is given, X value they have given 3240. Subtracting these two values, we get 240. And now considering the standard formula Z equal to X minus NP by square root of NPQ. So by substituting all the values, we will get the value as 5.4, which is greater than 2.58. We can give the conclusion that thus the hypothesis is rejected at 1% level of significance, and we can conclude that the die is instead of unbiased, as we considered unbiased here, so as we are rejecting the hypothesis, so therefore the die is biased. Moving on to next problem. A sample of 900 days was taken in a coastal town, and it was found that on 100 days the weather was very hot. Obtain the probable limits of the percentage of very hot weather. So this is another category of problems under large sample. So they have given n, that is 900. So I require to find out the probability of success called here hot weather. Probability of hot weather is given by P equal to, so out of 900, so it is given as 100 days. Out of 900 days, 100 days will be an hot weather. So therefore 100 by 900 will be 1 by 9. So I can come to know what will be Q. When I come to know what is P, I will come to know Q value 1 minus P. By doing that, Q value is 8 by 9. So as the problem is asking to find probable limits, we are using this formula. Instead of P, there is some of them, or some textbook will be used as X bar plus or minus 2.58. That is what the confidence intervals we have used the formula. So you can use this formula, X bar plus or minus 2.58 into square root of 2PQ, square root of PQ divided by N. Using this, I have substituted the values. This is P value 1 by 9, Q value is 8 by 9, and 1 over N is 1 over 900. Solving this, I am going to get two values. For plus or minus, you are going to get 0.084 as we are subtracting. Once if you add, you are going to get 0.138. So therefore, probable limit of very hot weather. Therefore, probable limits of very hot weather is given by, in terms of percentage, you should give. Multiply this value by 100, whatever the value you are going to get, multiply that value by 100, it will be of 8.4% to 13.8%. It should be always lower to higher value, 8.4% to 13.8%. This is another category under large samples. So one more category I have considered under large sample, This is the last problem under large samples I have considered. So these four categories are very important while solving large samples. A sample of 100 students is taken from a large population. The mean height, see here they have given mean height of the student in this sample is 160 centimeter. Can it be reasonably regarded that in the population the mean height is 165 centimeter and standard deviation, they have given standard deviation is 10 centimeter at 5% level of significance. So now they have given x bar, x bar equal to 160 centimeter, that is mean height of the given sample. Next given n, it is 100, and now also I told you that mean height is 165 given, and also with that standard deviation sigma is given, so sigma equal to 10 centimeter. Now you should use the formula z equal to directly z equal to square root of n x bar minus mu by sigma. So using all the values you are going to get the values minus 5 here. I have told you that we will consider mod z. So mod z will be equal to 5, which is greater than 1.96. This is nothing but this value is 1.96. So which is great, as it is greater than 1.96, we can tell that the hypothesis is rejected at 5% level of significance. So these are all the four categories you require to study and be thorough with this type of problems. Definitely in both the choice, one problem will be compulsory of these types. Next, moving on to student t distribution. I have considered one problem on student t distribution. If you know only one problem is enough, so rest of the problem can be solved by yourself. I have considered the important problem under student t distribution. A certain stimulus administered to each of the 12 patients results in the following change. See, this is the values given x1, x2, x3, so on. This is the values they have given. Concluded that the stimulus will increase the BP, blood pressure, and they have given 11 degree of freedom at 5%. This represents 5%, 2.201. So as they have given n values 12, n equal to 12, so the degree of freedom will be 11. So if you get whatever the value less than this value, then it will be accepted. If it is greater than this value, then the hypothesis is rejected. So now you write down the given. Given is x equal to, this problem is what? Student t distribution. Student t distribution. So by given data, we are decided to apply student t distribution. So for student t distribution, you know the formula. It is given by square root of n times of x bar minus mu by sigma. This is the formula. So in this, we required x bar, mu and sigma. We are going to find out that one. So x bar can be found out by summation x divided by n. So which is nothing but sum of all the values of x, that is 31, divided by given value n, it is 12. So therefore solving that, you are going to get 2.58. So then we know that sigma square I have given in the list of formula. Sigma square is equal to 1 over n minus 1 times of summation x minus x bar the whole square. So 1 over 12 minus 1 times of 5 minus, this is 5 minus 2.58 whole square plus 2 minus 2.58 whole square plus 8 minus 2.58 whole square plus minus 1 minus 2.58 whole square, so on etc. up to 6 minus 2.58 whole square. So solving this, what you are going to get? We are going to get 9.538. That is sigma square. Taking square root on both the side, we will get sigma equal to 3.088. So this is the value of sigma. Then substituting these values, mu, x bar, and whatever. So here mu is not given. We should assume that since by observed data there is no increase in blood pressure, so we consider mu equal to 0. In some cases they will provide you the mean of the distribution, so you can consider that mean value and substitute that value. In this case they have not given, and we observe by given data, we observe that there is no increase in blood pressure. That's why we consider mean value as 0. So substituting all the values, we observed that we got the value of T as 2.89. So approximately it is 2.9. So which is greater than 2.201, which is at 11 degree of freedom. Therefore, we conclude that the hypothesis is rejected at 5% level of significance. So we conclude with 95% confidence that the stimulus in general is accompanied with increase in blood pressure. So this is just an example I have given how to solve the problems of student T distribution and sample of large size. So thank you all. I think you all understood the concept. If you all like this video, kindly do subscribe to my channel and don't forget to press like button. Thank you once again.